Happy post-holiday, Christopher.
Yeah, it still feels like holidays because I've got another Christmas to go to this weekend and then one next weekend. So
What?
it's never ending, man.
Like family or friends?
Yeah, family stuff.
Eesh.
How about you?
Uh,
How are you?
I'm good. Christmas was fun with a 2-year-old. He was excited. I stayed up Christmas Eve putting together toys, I guess like you do when you become a parent.
Mm-hmm.
And it was a little kitchen because that dude loves like kitchens. And I was all like, it was like midnight. And I opened the box. It's like, oh, easy to install. And then there were 39 steps. And I was like, that is not my definition of easy.
You got the IKEA one.
We, we actually, there was an IKEA one we almost got. And I think it would have been easier put together than this.
That's hilarious.
So yet again, we are not alone today. Today we are joined by Noah Gibbs, and I will let Noah, if you don't mind, just give us like a brief, whatever you want to say about yourself.
Not at all. So I wrote a book called Rebuilding Rails. That's probably what most people know me best for. I also do a lot of writing about Ruby performance at engineering.appfolio.com. Appfolio is my employer, and they pay me to do this stuff. So thank you, Appfolio. I also just so I've said it because it seems relevant. My kid also has a little play kitchen, but both of them, and they both love it. My older girl and my boy both love it a lot. So all in favor of play kitchens. Yeah,
Their fascination with kitchens, like he keeps coming up to us though with like a bunch of stuff in a pot. He's like ready, and I just like fake eat it. He loves it, so
perfect. Well, they want to do what you do, you know.
I guess they should be ordering McDonald's then. So. All right. So today Chris and I were just wanting to pick your brain about Ruby. On this podcast, we talk about like, Ruby 2.6 is coming and it comes with a just-in-time compiler. And we're like, cool. And that's basically all we can talk about. But you actually gave a talk at Southeast Ruby on the JIT. So we feel that you are overtly qualified for this.
It sounds good to me. Well, I'm always happy to talk about Ruby, and yeah, talking about JIT's a lot of what I do lately. I don't know how many folks out there subscribe to Ruby Weekly, but you may have seen my stuff talking about JIT among other things out there. What do you think? Should we start with what JIT is, or where do you want to start?
Let's start with what it is.
All right. So there's languages that are interpreted that read a pretty straightforward version of what the code says, and then they just kind of go over that and they do it as it says it. They go over those steps. There's other languages that are compiled. I immediately think of C, but like any of the old systems languages, anything you would have started on, 20 years ago, it tends to be compiled. It builds a native app out of your code, and then the original code's gone. All that's left is that that version that's just an app that runs in the machine language of the machine. JIT is kind of straddling in between those two worlds. It starts off interpreted, and then once you've hit a particular piece of code enough times, it goes, well, if I compiled this to native code, it'll run faster. Maybe I'll do that. And so usually it kicks off a background thread that a little bit later turns that interpreted code into native code, and then it quietly swaps that out so that the next time after it finishes that you call that, you get the native code version. And with luck, it runs a little faster. It takes a little more memory because you've got a new version there, and you've probably noticed that a compiled native app tends to be way bigger than your Ruby source code. So it takes a little more memory, but it runs a little faster, which for most people is a good idea these days.
Awesome. So what kind of performance gains, like we'll talk about Rails in a second, but just on like Ruby applications, what kind of like performance gains do you think the average person will see?
So in the English-speaking world, which is going to be most of your podcast listeners, a lot of people, when they hear Ruby, think Rails. And I've got very disappointing news that I ought to get out right up front. The Ruby 2.6 JIT is going to do you very little good in Rails. Especially a big Rails app, especially a more complicated Rails app. The JIT actually slows it down at this point. So I would recommend not turning on JIT for your big Rails app. But at the same time, if you do something in the background, if you do something that does calculations, if you do something else that actually spends a bunch of time spinning on Ruby, there are things where the 2.6 JIT is 2.5 times as fast. for the kind of thing that you might otherwise call out from Ruby to something else. And 2.5 times faster may be fast enough that you can do it in Ruby instead of doing call out. So that's nice.
Yeah,
Yeah,
that's
that's awesome.
significant. Last I had heard was like the OptCarrot being like 1.7 times faster. So that's even more fast than that.
Yeah, what I've seen from Takashi Kokubun, who is the primary person working on JIT at this point, is that is that 2.5 times is about what he gets out of OptCarrot. So it's improved since then. It's doing better.
That's fantastic.
It
So,
is.
um, so how much complexity does the JIT add to to MRI itself, like the implementation? Is it going to be much harder in the future to add like features to Ruby, or how's that work?
So there's a little bit. I mean, JIT is always complicated, and if you look at the JRuby guys who work on the JVM, an awful lot of their work is about JIT. Though that's also partly because they focus so much on speed, and so since a whole bunch of their work is about speed, a whole bunch of their work has to be about sleep. Sorry, has to be about speed. But in general, it's not bad. So Ruby has always had a little set of chunks of C code, one chunk of C code for each instruction that it runs as it does each instruction in what's called the bytecode underneath. And so they've basically, instead of just having one big loop with all those things and it jumps to each part of the loop as you go through each instruction in turn, instead what it does is it uses that to generate the C code that winds up getting compiled for JIT. Ruby JIT is a little bit weird. It's not the same. It's not the same kind of JIT that you see in most languages. It's really not very similar to JRuby's JIT or Java's JIT. So most JIT, what it does is it directly compiles from the interpreted representation in memory into machine code. It does that in your binary. Ruby is unusual. Its JIT in 2.6 is unusual in that it actually generates a C source file, like in your temp directory usually, and then runs your C compiler on it, and then loads that library, loads that compiled code in, which is not the usual approach. But one of the cool things about it is it's very low complexity as far as Ruby goes. When you ask, is it going to be harder now to add Ruby features? Not as much as you'd think, because Ruby actually keeps almost the same code for everything that it did before. It just uses some of that code in a new way as well.
Oh, that's interesting. The only real experience I had was using Python and seeing all those .pyc files get dumped into your directories whenever it compiled stuff down to bytecode. So that was like kind of my only experience with that, and never really understood the differences between like how they implemented that. And Ruby's going to, or the JIT will compile this whenever you start Ruby. It's not going to cache the compiled stuff, right?
Right. So interestingly, the PyC stuff, the bytecodes, Ruby doesn't by default ever do that, but that's actually closer to what Bootsnap does. That's actually
Oh,
doing the
okay.
parse pass in the beginning and saving that. It is really hard to make sure that those files stick around, that they're appropriate, that they're correct for the platform you're on, that there aren't any changes in Ruby version or Python version or whatever. Like that is really hard to do. And that's actually why Bootsnap is normally used in production for a deployed thing so that those cache files should never change. But yeah, Bootsnap does almost exactly that. It's not built into Ruby by default. You add a gem that does it on top of it.
That's super interesting. I didn't realize that, but it makes a lot of sense. And yeah, that there's definitely, all those little details of what platform it's running on and everything that needs to be kept in check. And then if you modify the source file, you don't want to keep running the old bytecode and all of that. There's so many things that you probably have to worry about in that situation. So
Yeah, absolutely. I mean, the thing that at some point stopped me from looking further into that, because I mean, it seems like JIT, because you repeatedly compile this thing, there should be this massive cacheable thing. You should be able to kind of slowly assemble a fully native app in pieces, and then save most of that. It seems like, I mean, just kind of conceptually,
mhm.
and in some ways, Truffle Ruby sort of does that, but it doesn't cache it. And what really stopped me is at some point, as I tried to think of, oh, well, you could just do this and it would fix some of it. Oh, you could just do this and it would fix some of it. And I realized the JIT doesn't cache any of that stuff. The JVM, the JIT, like Hotspot doesn't cache any of that stuff. And so when I thought about, oh, well, it's got to be pretty straightforward, right? Then I thought, there's no reason any of these solutions I've come up with couldn't be used for the JVM. And they don't. They never do. Whatever this problem is, it's so hard that on the JVM's budget, with its number of implementers, they've decided this is too hard to seriously get into.
Oh, wow.
Oh. That's not a good sign for us just figuring it out by Tuesday.
No, wow. That's fascinating.
So you mentioned that, and I'd seen this, you mentioned that Rails project with JIT enabled is actually slower. And I think I read somewhere it's like 25% slower. Does that sound right?
You'll see different numbers. I found in Preview 3 that my particular test using a big concurrent discourse benchmark was about 10% slower in Preview 3, and then was 60% slower in the released version. And so you're going to see numbers all over the map. And I think that's a lot of it's that Takashi's been trying different things and trying to fix it up. And but there's a necessary trade-off between stability and speed. And I think Preview 3, which was kind of crashy, went all the way in the speed direction. And then by the time he was getting into the release candidates and just about to get to the release version of 2.6, he was turning all that unstable stuff off. And so it was a lot slower, but it also, is rock solid and doesn't crash.
Sure. So I'm trying to ask, what are kind of like some of the technical reasons why it's slower in a Rails project than just running pure Ruby?
Sure. So one reason that it can be hard, the Truffle Ruby guys, sorry, I should introduce that for listeners who don't necessarily know. So Truffle Ruby is an extremely powerful, complicated, early experimental version of Ruby that uses extremely powerful JIT implementations using what's called Truffle and Graal. It's called Truffle Ruby because it's built on top of the Truffle interpreter / compiler kit. But it's basically by far the most complicated and effective optimizer for Ruby in existence. It doesn't work with everything yet. It's experimental, and it does not run most Rails apps. It has a lot of trouble with the database gems for complicated reasons. They're working on it. They're trying. But so Truffle Ruby is kind of the gold standard as far as JIT. Like if Truffle Ruby can't do it, then even the people who are trying the hardest on this have not figured it out yet. Truffle Ruby gets better month by month too. Sure. Anyway, sorry. So you asked about Rails and why Rails is hard, why it slows down. The Truffle Ruby guys point out that you should really never JIT a method that will get slower. And that's a very good thing to point out, and they're basically right. And to do that, you have to have complicated criteria for what you JIT and when you replace it. And sometimes you wind up doing some optimization and then discovering it doesn't work and throwing it away. All of that is more complicated than anything that imjit in 2.6 does. Imjit in 2.6 is very straightforward. When you hit a particular method 5 times, it queues it up to be JITted. It has a background thread that will quite slowly go through and JIT methods one at a time in the order they were queued up, in the order that they hit 5 calls. Even if it's slower, it'll still replace it. It doesn't have any useful way to evaluate the 2 pieces of code and see which one is faster. And it doesn't track it afterwards. It won't throw something away if it turned out it was faster. There's a lot of ways you could track this in complicated detail, and it does none of them. Truffle Ruby does quite a lot of them. And so there's part of the answer for how this could happen at all, for how you could have a system which, once it does the JITting, it then puts the slower thing in place and leaves the slower thing in place. So there's part of your answer. But then why is it hard? Why is it hard to JIT a Rails app compared to a non-Rails app? So if you guys do profiling, you're probably familiar with several of the really basic rules, like always profile before you optimize, figure out what's slow before you speed it up, and the whole 90-10 thing. As a rule, with a new program that you've just sat down to optimize, that you've never optimized before, 90% of the runtime is going to live in 10% of the code. And so the hard part is finding that 10% of the code, and then you stare at it and you fix it. And so usually when you profile, as a human, JIT does kind of the same thing, but as a human, when you profile, you find the slow part, you work on the slow part, the slow part gets sped up. And now you have more of your code to be 90% of the runtime because you've taken that central chunk and fixed it. And the kind of, what's slow now spreads out from there. And then you find the next slow thing and you fix it. The next thing is slow thing and you fix it. And eventually you get to the point where it's not a really sharp peak like 9010, where it's not this tiny chunk of your code that is almost all of the runtime. Because every time you fix one of those bugs, it kind of spreads out just by taking out that sharp peak. JIT has very much the same effect. JIT does really, really well when there's a few methods that take up almost all of your runtime and there's some obvious way to speed them up. And so in optcaret, for instance, that's pretty true. Optcaret, JIT does a really good job. Truffle Ruby does a good job. MJIT does a good job. Like it's code that JITs very well. Rails has been optimized by humans for a very long time. They've been working on speeding it up. They do a really good job. They work constantly at it. And as a result, there's not one tiny bit of Rails where all the time gets spent. Instead, it's got this more spread out effect where they've fixed the obvious problems one after another, until to speed up Rails, you're not looking at one tiny chunk of code that is 90% of your runtime. You're looking at 30 different methods or 50 different methods that you have to speed up all of them noticeably. So for starters, that's hard. Like the easy part of JIT is you find something, you find a way to speed up one kind of problem, you deploy that, it speeds up that one kind of problem. Yay, cocoa and schnapps all around. And if you've got one tiny program with that one tiny problem, you've just fixed everything and you get to be a hero. But if you've got a program where everything is written pretty well, and so it's hard to optimize, and there's 30 different things, and you've got to optimize them all to make any noticeable progress, until your JIT is very mature and very good at a lot of different things, you're not going to gain much. And so, yeah, usually... with JIT, the big gains come on the small benchmarks first. Truffle Ruby has this too. I mean, if you look at it early on, especially, they were very slow for all kinds of things, and then they slowly got fast on this one kind of thing, and fast on another kind of thing, and fast on a third kind of thing. They added these speed ups one at a time by fixing these individual cases. And the difference between running, say, Discourse, which is a big piece of open source forum software running Rails, and running optcaret, is that optcaret is a really simple thing. There's 5 or 6 things that if you can speed them up, optcaret is fast. And Discourse is this giant sprawling thing that does thousands of different operations in different ways. And if you've sped up the first 100, you still haven't necessarily made all that much of a difference.
That is probably the best explanation I've heard on explaining that. So is it... Let me recap, make sure I'm on the same page, though. So essentially, like, you're saying there's the 90-10 where, like, 90% of your code is, or 90% of, like, your performance is, like, just 10% of your code.
Yeah, and that's how it starts. On a fresh new program you just wrote and you've never optimized, that's a good rule of thumb.
So Rails is, like, iterated on that to where that's not necessarily the case anymore.
Yeah. So base Rails, if you looked at, say, Rails 3 right after they rewrote it, was a lot closer to that because they thought, oh, we're going to make this wonderful, very pretty architecture that isn't necessarily very fast, but it's very elegant. And then they were back to a case that was more like that. But the thing is, since Rails 3, they've made an awful lot of changes. Like Rails has gotten a lot faster since Rails 3. And as a result, and the way they've done it is to say, oh, well, here's this case that's slow. Let's fix that. And every time they do that, they spread it out more. And so a perfect code base, if there's any such thing, is going to be more like 50-50. Half of your code is half of your total runtime spent. Not exactly. There's no such thing as perfect code by that definition, other than straight line equal time on every line. But like 90-10 is fairly extreme. The idea that a few tiny chunks of your code take almost all the time is fairly extreme. And you slowly move down to, okay, this code is more like 80-20. This code is more like 70-30. Until you get to whatever your closest to a near ideal is. I don't know, 60-40, 55-45, something like that. I don't think you could get much more even than that with real world code. And yeah, so it kind of spreads out. And Rails has been optimized and optimized and optimized till most of the really hot spots aren't that hot anymore.
Huh. So is it possible then, like, as the JIT matures, like I know it's so fresh right now, that we'll ever see like performance gains with it in Rails, or do you think?
Absolutely.
Okay.
Absolutely. So the thing to remember about MJIT versus, say, Truffle Ruby is that Truffle Ruby started from nothing and has been working kind of quietly in the background for years on this. Like they have a substantial head start in terms of JITting. They also started building on the JVM, which is to say,
Right.
their 0 point was already the fastest thing in the world at that point. Uh, and so, yeah, there's every reason to believe that things will keep improving. I mean, when you see, at Preview 3, it was like within 10% of not making any different, of not doing any harm, and now it's up to 60% or whatever. It's really easy to look at that and go, oh wow, that's never going to go anywhere. But the fact that it's in place I mean, how long did it take them to write it? Say a year and a half, which is ridiculously fast for a new JIT implementation. And that it's not helping on Rails apps, but it's helping on small apps. And you can turn it on Rails. It runs in Rails. It doesn't crash on Rails. It's just slower on Rails. This is actually kind of crazy fast speed. It's like this is early days. This has just been released for the first time, but to compare speed-wise with maybe other things in Rubyland, like guilds were a theory for a long time, and at this point they exist, but they're not really even stable enough to go into the final version. Like guilds are not even as far along as JIT.
Oh wow.
Yeah. They're in a branch on Koichi's Git repository, which is not bad, and they can do some interesting things, but they're definitely not as far along as JIT. And given how big and complicated JIT is and how hard it is to do right, it's very, very impressive that they've done as well as they have this fast.
Wow. Yeah. What's sort of the plan forward on it? So are they going to be working towards more of those metrics to figure out, like potentially, I guess you could, if you're measuring which pieces of code that you JIT and are slower, then in theory you could turn on the JIT and get more or less the same performance as having it off. If it's able to tell that the JITted version is slower, we can just ignore that. Is that something that they'll work towards?
I don't know if that specific thing is something they're working towards. You could ask Takashi about it, I guess. I don't know of an effort to do that specifically. Instead, he's just trying to get the optimizer to be better, so that it's not going to be.
Seems like a more useful place to spend your time here at the beginning.
Yeah. It's definitely a lot more like how other JIT implementations work. Basically, he's started off by kind of dropping it in at all, and the rest of the work on JIT is almost always just add an optimization, tweak an optimization. One of the big things that JIT does really well in general that MJIT, I think, still doesn't do at all is method inlining. One of the big advantages that JIT has over no JIT, and that can make Ruby a lot faster, that Truffle Ruby gets, is if you are calling a method and you inline it, you substitute the body of that method into the place where you're calling it, then an optimizer can kind of look at that and go, okay, well, in general, this method checks this, this, and this to make sure it's sane, just like a, return if this thing is nil or whatever. In these cases, I know that we can skip all of those checks. So those checks go away completely. And it can do that in the optimization phase. It can do that when you call the method. It can say, well, you say you're calling this method, but like half the method doesn't do anything, so I'm just going to take it out. That is one of the most powerful tricks that JIT does, is to look at how a method is called in a particular circumstance and effectively call kind of a reduced version of that method that only does what it needs in that one case, not everything it could possibly do. And again, MJIT doesn't, I think, do that at all at this point. And so, yeah, there's a bunch of things like that. There's a bunch of major JIT tricks that, because MJIT is so new, it just doesn't do. And so there's definitely a lot of room to improve along those lines. And I think what we're going to see soon is more like that, is sort of major JIT features that MJIT barely does or doesn't do.
Very cool. Do you think these things will be coming out in Ruby 2.7 or like patch versions or whatever in 2.6?
There's probably going to be some in patch versions in 2.6, but the patch versions, they're usually pretty conservative about only the safest changes, has been my experience. Patch versions tend to be released in response to like security problems and things like that. So my guess is that major JIT changes either won't come out in the patch versions or will will only rarely come out in the patch versions. I mean, you don't want the patch version to have sort of the latest, most raw JIT. You don't want it to be the equivalent of the changes in Preview 3 that were, again, a lot faster, but also kind of crashy. Like you don't want that in your patch versions.
No.
Now, the flip side of that is if you do want that kind of thing, go to Head of Master. It's actually never been easier to have RVM install a random, Git revision of Ruby where you want it. A lot of the way my benchmark stuff works is I give it a Git revision and I tell it, hey, build this Ruby and install it. And you can not only tell RVM that you want a pre-release Ruby like Head of Master, you can also build a Ruby and then tell RVM to mount it, or whatever version manager you use. Like it's not that hard to do these days.
Mm-hmm. Yeah, that's a great point. You can kind of fiddle around with that stuff, and I guess if you did find one that worked well for you, you could run that even in staging or whatever that you wanted to do, and just kind of experiment and see how fast it is on your app in a more real world scenario there.
Yeah, and I mean, if you don't want the full Head of Master experience, and particularly in production, I understand why you wouldn't. The previews are often very stable. Like Ruby in general, any release that they label tends to be pretty good, and so the preview releases are often not bad. Again, Preview 3 this year was pretty crashy, but one reason I keep bringing it up is because that's so rare. Preview 1 and Preview 2, while they were a less advanced JIT, were shockingly solid.
Yeah, I've pretty much always stuck to the stable version, so that's something I should play with more in the future, is seeing how, at least especially in development, seeing how well the preview releases are doing.
Yeah. Well, one advantage there is if there's something specific you want and you try it with a preview release, you can go talk to the people who are doing the work. I mean, if you're on a release version of Ruby, it's going to be another almost a year until you can give feedback, have them incorporate the feedback, and then you can use it in another released version, right? Whereas if you go to Takashi and you say, hey, like I'm on 2.6, here's this thing, it's a really simple change, I wish JIT sped it up a lot. And he said, oh yeah, I can do that, no problem. And 3 weeks from now, he's got it beautiful and stable and done and in Head of Master. Well, if you use Preview 1 of Ruby 2.7, then you get that immediately instead of having to wait until next Christmas.
Yeah, that's a great point. I like it.
Yeah, that's something I've never even thought about. So how are we in terms of hitting 3x3?
I think that we're going to see JIT speeding up Rails apps decently in 2.7. I'm guessing. I mean, it's way early. It's hard to tell. That's a year out. But I think we're going to see it. And we're 2 years out from Ruby 3x3 being released, according to Mautz's current best guess. That was what he said at RubyConf. So I think we're going to see 3x for small apps or Ruby heavy apps, like Optcarrot is probably going to be well over 3x by then. I don't think you're going to see actual 3x on most Rails apps because so many of them are IO bound and database bound. There's a lot of stuff that just isn't Ruby in there, and it doesn't matter how fast Ruby is; it's not going to speed that up 3x.
Cool.
Yeah, I was going to just mention, I think that's a lot of the stuff that people don't realize is, anytime you're making a request to Redis to get data or Memcached or whatever, those are all things that your Ruby code is just sitting around waiting. It's not actually, running code. So you won't see any speed ups from any of those IO things. And, most beginner Rails developers have no idea sort of where those things are happening, because they're kind of nicely hidden away from you for the most part, making it easier to pick up. But it's also harder to grasp exactly what's happening when, your views render, but they hit the cache and pulled some data back. And then, your views are taking X amount of time and you can't figure out how to speed them up. Well, it's also doing this IO in there. So you need to make sure you have, a fast connection to your cache and all of that too.
Yeah. What I'll say about that for Ruby 3x3 is that guilds look like they might have some really interesting possibilities there. Something that the JRuby folks look at and kind of get to snicker at the CRuby folks, like me. is that you can get much better use of a large server by running threads instead of processes. And Ruby threads, as you probably already know, we've got the GIL, the global interpreter lock. So a single Ruby process cannot be running Ruby code at the same time in more than one thread at once. We can be waiting, like we can be waiting on Redis in 3 threads while we run, Ruby code in another and wait on the database in 2 other threads. That's fine. But we cannot be running Ruby code simultaneously in more than one thread right now. And we do use multiple processes. You can definitely say run Puma in cluster mode and run Ruby in more than one process, one thread in each doing it. But that wastes memory, because by having multiple processes instead of multiple threads can all share the same memory and multiple processes can't. And so you wind up running out of memory on your machine before you have as many processes as could potentially help you out. And so with guilds, which potentially allow you to run Ruby in more than one guild, like a thread, in the same process, you could take your big server and you could, instead of running, say 10 Ruby processes, which is what I run on an Amazon EC2 M42X large, that's about optimal. Instead of running 10 processes with 60 threads, which is what I do, you could run one process with probably less than 60 guilds, with, 30 guilds, something like that. I have to actually time it out, and it depends how guilds wind up. But you could potentially get a lot more total requests out of a given size of instance by using this more efficient method to run more threads at once. It's an awful lot like how JRuby works when it runs Rails. Like JRuby, you just want a whole bunch of threads, and since they can all run Ruby code in parallel, JRuby on Rails winds up using the same instance more efficiently, at least assuming it's got a lot of memory, because JVM needs a lot of memory.
Wow. Okay. Yeah. What's the status on the guild stuff? I don't think I've really looked into that at all for quite a while.
That's fair. So Koichi Sasada, who is the head of the C Ruby team, for most stuff day to day, has been working on guilds quite a lot for a while. For a while, it was just kind of private experiments that he did, and he kept the code private. But at this point, he's released it. You can see the code. It's not in mainline Ruby, but it exists, and you can just find it on his GitHub. Guilds are a really interesting idea that if your threads aren't sort of cross-modifying mutable objects, if you don't have one thread reaching into another thread's objects to mutate it, then you should be able to kind of do it Erlang style, where each thread has a bucket of their own mutable things, and immutable things can be shared. And you can get approximately thread performance as long as you're not handing mutable objects back and forth or having multiple guilds mess with mutable objects. A lot like threads when threads are working well, just with more actual ability to tell when you break the rules and prevent you from breaking those rules. Koichi has an interesting first implementation that can work in some cases, but it's really heavyweight right now. Adding a bunch of guilds takes a lot of resources right now. It can be very slow. It can take a lot of memory. It's definitely an experimental implementation, not a final production, go use it in your server implementation. He's actually looking at ways he can change the API for guilds, the definition of how guilds work from the current one, to try and improve the performance. If you watch his talk from RubyConf this year, it's very in-depth, it's very technical, but also a lot of what he's saying is here's a case where it works. It's a great big heavy, thing, and still, like, the trade-off is significant. Like, guilds wind up taking a lot of overhead in order to fix this problem. And so he's looking at how to change the definition of guilds to be able to make them lighter weight but still work. I think they're going to work out, but whether they're going to be an easy choice in the places you would otherwise use threading, I don't know.
Yeah. And this was one of the potential ideas for 3x3, right?
Yeah. Well, so what 3x3 has sort of 3 major pillars. One is performance. The idea is it'll be 3 times faster. The second one is concurrency. We want Ruby to run better on big servers or other highly concurrent scenarios. And the third one is the type system. So those are the kind of three pillars of 3x3. The primary concurrency thing that we've been looking at is guilds. The idea of a new concurrency primitive. That's not the only concurrency work that's been done. I mean, Ruby is used for a lot of different things, but that was going to be the big new idea about how concurrency is improved in Ruby 3x3. Yeah.
Okay. Yeah, that's interesting. Because I remember them talking about that, but I don't think I ever really kept up with any of the progress on guilds. What about the type system stuff? Any new things there?
Okay. The type system stuff is interesting because there's not a good good consensus on what that's going to look like yet. So the type, if concurrency was mainly done with a blessed developer doing something where they had a pretty good idea of it and sort of ground on it in the background for a while until there was a prototype ready, the type system worked the opposite way. The type system was almost a bake-off, where a bunch of different people had interesting ideas, prototyped the ideas, came up with the prototypes and talked about them and kind of showed Mats and said, I think this ought to be our type system change for Ruby 3x3. And mostly Mats said, no. So there have been a bunch of people doing type annotations. You've probably seen like Ruby contracts and stuff in various
Yeah, I
little
think
gems.
so.
Yeah, you've probably
They're
seen
kind of like what comments or something you put in that, or something similar to that kind of
yeah,
add the type.
yeah, annotations work almost like the public or private keywords, but you can do the same thing with method calls in Ruby. Like you can run a little thing in your class where if you run it at the class level, like if you call that method at the class level, it changes what the class does next. You can literally implement annotations as method calls in Ruby as it currently
Yeah.
exists.
Yeah, I guess you could.
Mats hates it and doesn't want us to do that. But despite that, you can. The language will totally allow it. It's not even that hard. Yeah, so Mats dislikes annotations pretty intensely and says that is not the way he wants to go forward. But that is something that several people have done. There's also, I don't know if you've looked at things coming out of, is it Stripe or PayPal?
Yeah, it's Stripe. They
Stripe.
had a thing called Sorbet.
Yes. And so there are some interesting, more restrictive type system things you can do basically for working on Ruby in very large projects. I've always thought the big cultural differences between a language like Ruby and a language like Java, and those are made even more intense by Rails, is the extent to which they trust you with sharp tools. You can find that stuff in the Rails manifesto, but a lot of what that means is if you want to make non-local changes that affect everything in the program, Java doesn't trust you with those tools because Java wants to behave the same, even if you've got a coworker over there that you know perfectly well shouldn't be trusted with sharp tools. And Ruby basically says, well, don't work with that guy or get used to pain.
Yeah.
But the flip side of that is you can have a thing like Rails that changes how Ruby works in fundamental ways, just exactly like you can, if you wanted to write a gem that added annotations to Ruby, turns out you could just do that and drop it in. And when it's required, it would just do that. Ruby is very willing to trust you with big, interesting changes that affect how the entire language works. And sometimes that's terrible, and sometimes it's great. And when it's terrible, with luck, you stop doing it. And when it's great, you get something like Rails or Rake that substantially change how the language works in interesting ways. So the type system stuff can definitely be something interesting of that general kind. Anyway, Sorbet is very much designed to take away a little bit of that sharp tool trust that Ruby otherwise has, so that using it in a giant group of developers on a giant app is less horrifically painful. Because Ruby is so expressive, a bad Ruby app can be bad in a way a bad Java app just can't. The flip side of that is a good Ruby app can be good in a way that the good Java app just can't. If you give people a lot of freedom, you'll get really good things and really bad things. And if you take away some of that freedom, it becomes possible to build bigger things that always have to kind of slowly tend to mediocre, Above a certain size, an app can't be worse than a certain amount or it falls apart, and it can't be better than a certain amount because you've got this large sprawling thing that people change everywhere.
Mm-hmm. That makes a lot of sense, yeah. The scale of what you're building ends up, when you have that many different, minds working on the same thing, it gets to be a thing where you're like, wow, we need some sort of structure here to make sure that things don't go too far one direction or the other.
Yeah. And, in Ruby, a lot of the things that you do, like, oh, I'm going to put in active support and change the methods on integer. The reason that works is because if it's a small focused program, you change something like that and you change how your entire program works around it. It's like you could change the laws of physics. Whereas on a very large app, by necessity, you've got a lot of, let's call it legacy code, but you've got the other 90% of the app, which is still huge, that doesn't use whatever brilliant thing you just came up with. And you're going to have to just deal with that. You're not going to change the entire app every time you have a new good idea. It's not feasible.
Yeah, or you can't, or you also have all these, if you have thousands of developers, they're not at all the same skill level as well. So, some people may be familiar with core functions from Ruby and just stick to that. And other people might be like, extending integer and sticking to their kind of thing that they're familiar with. So having those like things where you can say, okay, we're not going to do that here, there, you can end up keeping it a bit more consistent for everyone. And that's sort of like the type system will help. If you want to add that consistency, you can go ahead and do that, which is cool.
And above a certain number of developers, you can't keep everyone on the same page. It's just literally impossible. And so you need to make allowances for that. You need to make slow, careful, kind of conservative, gradual changes. And so a language like Java, which has a lot of safety rails, is much, much better for that. And in the same way, you can restrict Ruby to have more safety rails and be much better for that. It's just that culturally, that's kind of the opposite of what we think of, say, Rails as being.
I have one final question for you.
Okay.
How did you get into kind of the internals of Ruby? Because I would consider you quite knowledgeable in that, and I don't think that's something you just look at Ruby and be like, oh, I understand this all.
So I have been a programmer for a pretty long time. I graduated with my basic undergrad degree in 1998, and I had let's call it a 15-year career in C before I started Ruby.
Okay.
And Ruby is, C Ruby at least is a C program. Like when you talk about the internals of Ruby, if you mean C Ruby, you're talking about a big C program. And it's a well-written one. As C programs go, it's not hard to get into. Though if you're used to Ruby programs, even a really well-written C program is pretty hard to get into.
Right.
It's a different scale, right? Like a big Ruby program might be 4,000 or 5,000 lines. And okay, a big Rails app is sometimes bigger than that, but 4,000 or 5,000 lines is a pretty substantial amount of Ruby, and 4,000 or 5,000 lines of C gets you up and gets you your coffee in the morning. Like it's just not that much C.
Yeah, right.
A large C program can easily be 30 or 40 or 50,000 lines, and more frequently is 200,000 lines or 500,000 lines. I know of C programs that are up to around 20 million lines. That's not. It's remarkable. It's unusual, but you wouldn't even think about a 20 million line Ruby program. Like that's not even sort of in scope of what anyone ever does or considers doing. And it's the Ruby interpreter, of course, is nowhere near that big. Anyway, sorry. So C, it's on a whole other scale from Ruby. But if you're used to C programs, Ruby is a really good C program. It's reasonably tight. It's well written. It's the nice thing about having Ruby programmers work on your C is that they're used to testing, they're used to commenting, they're used to things more or less saying what they are. A Ruby program translated into C tends to be a good C program because it tends to have a lot of meaning. It tends to be written by people who keep track of what they're thinking of at any given time when they're writing it. It's not that you can't do that in C, you totally can, but a lot of C programs aren't that good because at that scale, it's easy to kind of sprawl and not keep track. Whereas somebody who's mentally translating from a much smaller, tighter program in their head has a pretty good idea what they're writing.
So you're saying that Ruby programmers make the best C programmers?
I'm saying Ruby programmers make very good C programmers, yeah. The best C programmers? Oh, man. I don't even know where to start on that. Other than maybe the best way to use C is in a small number of specific places where you have to, that have C's absolute virtues. And one of those absolute virtues is that you don't use it for something conceptually big and sprawling. You use it for something conceptually small and tight. C is good for device drivers. C is good for operating systems. C is good for language interpreters. C is good for things where conceptually it's a small tight ball. And so you don't, while a full-size application written in C would be a horror story, and yeah, seriously don't. And so a Ruby programmer would be better at writing that because they'd be thinking in Ruby while writing in C. Even better would be writing in Ruby while thinking in Ruby.
Sure.
Anyway, so sorry how I got into it. So yeah, I've known C for a while. I started from C and came into Ruby, and Ruby seems like utter magic when you come from C. Like, Ruby is so weird coming from a language that doesn't really have a runtime. C doesn't have a garbage collector. It doesn't do stuff in background threads. Even its standard library is composed of things that would be trivial in Ruby. And you can turn it off. It's optional. In C, you're allowed to just run with the language and not have a standard library if you want. And I come from embedded C, where that kind of thing is more common. And so having this whole set of things the language does for you, this kind of ecosystem of the language running all the time, is fundamentally foreign and weird if you come from C. Yeah, so it took me a while to learn Ruby, and it really took me a while to learn Ruby along with like SQL and JavaScript and HTML and all these things that you do when you're writing in Rails.
Right.
And a lot of the way I came at those things was to say, okay, this looks like blasphemous magic, but it clearly runs. I write the example, I run the example, it works. How far down do I have to go into the implementation of it before I understand why it works? And so a lot of what I did was to take stuff apart constantly. Oh, this runs. There's no reason it should run, and it's bizarre that it runs. Let's take it apart and see what the pieces look like. And I did that with Ruby, and I did that with Rails. If you've seen my book is very much doing that with Rails. Like, understand Rails by writing the Ruby metaprogramming stuff that makes the Rails tricks work. It's the sort of the weird little trick for each Rails feature is generally some standard piece of Ruby metaprogramming used in a fun way. In the same way.
That. I was going to say, I noticed that coming from, I had a background in Python where everything was very explicit, and then coming to Ruby, it was like, where the heck are all these methods coming from and stuff? And, not importing everything at the top of the file, and write a controller, and the params method is just something we expect you to know about. And you're like, where the heck did this come from? And I really had a hard time with that until I read the metaprogramming Ruby book, and it was like, here, like you were going to write all this code anyways, but we wrote it for you and hid it away. So as long as you understand that it exists, you don't have to worry about it. And I was like, oh, that's fascinating. Like, everything else was very explicit in Python land. And then I realized that is sort of, it just approaches it with a different philosophy,
Exactly. But a lot of it is learning where to dig for it. And so I got pretty good at learning where to dig for things. And it turns out in Ruby land and Rails land, when you're trying to figure out where to dig for things, very often the answer is the Ruby interpreter source.
Yeah. Yeah. And even if you're just a regular Rails dev trying to debug things, like, just go to the source code of the gem, and whenever you get the stack trace, just like look for the line of code in the gem where it last crashed, and then just take a look on GitHub, and you're going to find the same things. And you can do that whether it's a gem or if you want to dive into the C source code for Ruby, you can do the exact same thing there.
Yeah, absolutely. And so, yeah, a lot of it is just the habit of digging. If you get in the habit of digging, you wind up in your app, and then you dig a level down, you get into a gem. You dig another level, you get into its dependency gem. You dig another level, well, okay, that thing's in the Ruby source code. Where's the Ruby source code? Well, it's on Git like everything else these days, if you want to find it. I mean, I've got it cloned on my machine at this point because I work with it all the time. But even before that, it's on GitHub. Everything's on GitHub.
That's awesome. Well, I'm out of questions. Chris, do you have anything else you want to ask?
No, I think this was a great deep dive into the JIT and everything. So we really love having you on. Thanks for joining us.
Way better than anything we could have done. So
it's been wonderful being on. If you find you got any more questions later, I'm always happy to talk Ruby. Thank you very much.
Yeah, and where can anyone listening to this find you on the internet?
The first place I tend to recommend is engineering.appfolio.com, APPFOLIO.com. That's where a lot of my Ruby performance writing gets written down. I have a personal blog that is mostly neglected while I'm writing there at work. If you subscribe to Ruby Weekly, you're already going to see a lot of my best stuff there. Peter tends to pick up a lot of my best articles, and so that's a great place. If you want to see more of the kind of things we talked about with the deep dive, my book Rebuilding Rails, which is at rebuilding-rails.com. If you give me your email address there, I'll trade you a couple of chapters free for it, right there on the email form. And yeah, if you like it, there's more there. I'm also on Twitter as Codefolio, Codefolio, and I am, again, always happy to talk Ruby on Twitter, on Skype, whatever. Like, you want to talk Ruby, hit me up.
Awesome.
Great.
Well, thanks so much for joining us, Chris. Do you have anything else?
No, I think that's it. We'll talk to you next week.
Yeah, we will. I think we have a guest again next week, so we'll just.
Ooh, will it be? Is it more of talk to you next year?
Yeah, we have a guest next year.
Awesome.
All right, we'll see you.
Cool. See ya.
Thank you. See ya.